Good day, grade 8s. Today we are going to be covering algebraic type of questions that you can expect in your exam. This specific video focuses on section A type of questions. For more advanced calculations and questions, make sure to watch the video to follow that would have the section B type of questions in it. To make sure that you do not miss out, hit the subscribe button and let's get into the paper for the day. Question 1. Let's match column A with column B by reading the following statements and then finding the algebraic expression that matches with it. Question A. The difference meaning subtraction between negative A and AB. If we look at all the options from number 1 to 10, we will see that the difference between negative A and B would be number 6. If we go to B, the quotient, which means the division of a certain number and the number B. If we go through the options again, we would find a certain number divided by B. Therefore, the solution by B would be number 9. C, a certain number squared. If we look at number 10, we have a number which is squared. Therefore, number C would fit with number 10. The next question reads, the average of A, B, and C. If we look at number 7, we have A plus B plus C. To get the average of these three numbers, we need to divide it with a total of 3. Therefore, the solution that fits with number D would be number 7. The last one, the product, meaning multiplication of A and the sum of B and C. If we look at number 8, we have the sum of B and C, which is multiplied by A. Therefore, the product of A and the sum of B and C is represented by number 8. In question 2, we are given the algebraic expression 3y minus a 4y squared plus a 6y cubed minus 2y. For the first question, we need to identify the number of terms within this algebraic expression. Remember, a term is something that gets separated by a plus or a minus sign. So if we start counting within this algebraic expression, we would have 3y as term 1 that gets separated by the minus sign. The second term would be 4y squared, and then it gets separated by the plus sign. Thereafter, we have 6y cubed, which gets separated then again by the minus sign, and then we have 2. Here, therefore, we have 1, 2, 3, 4 terms within this algebraic expression. The next question reads, state the degree of the expression. The degree, again, is the highest exponent that we find within this expression. Within the expression given, we have the exponent 2 and we have the exponent 3. Between these two, the higher exponent is 3. Therefore, the degree of this expression is 3. When we get to question 3, it says, write down the coefficient of y cubed. If we look at y cubed, we see that the numerical coefficient in front of it is the number 6. Therefore, this answer would be 6. The next question then says, state the value of the constant term. Remember, a constant is something that cannot change, and it is the term within the expression that has no variables or letters with it. When we look at the 4 terms, we see that in the 4th term, there are no variables with the negative 2. The term or the number is negative here, and therefore we say that the constant term would be negative 2 within this algebraic expression. The next question then states, write the expression in descending powers of y. We need to now reorganize this algebraic expression, starting with the term with the highest exponent in terms of y. We would start off by saying 6y cubed, which has the highest exponent. The next term would be negative 4y squared. Thereafter, we would have positive 3y. And remember that even though we do not write down the exponent if it's a 1, y has the exponent of 1 with it. Hereafter, what is left would be the constant term, which is negative 2. For our next question, we are given the algebraic expression AB minus BC plus AC. We need to determine the value of this expression if A is equal to 3, B is equal to negative 2, and C is equal to 0. We will now be substituting these values into the expression that we are given. Let's start. Where we have an A, we need to insert a positive 3. Therefore, we would start off by saying 3 multiplied by the next value is B, negative 2, close up our brackets, subtract another B, which is equal to negative 2, and C, which is equal to 0, plus A again, which is equal to 3, and then C again, which is equal to 0. We now do the multiplication first, so we would start off by saying 3 times negative 2 equals to negative 6. Negative 2 times 0 is 0, and therefore we would subtract the value 0 from negative 6. 3 times 0 again is 0, and therefore we would add 0 to this. If we then go negative 6, subtract 0, adding 0, our final solution would be negative 6. Question 4. Simplify the following. With the first question, we have A plus a A plus a A plus another A. All these A's are like terms, and therefore we can add them. We would go 1A plus another A plus another A plus another A would equal to 4A. The following question, we now have A multiplied by A multiplied by A multiplied by A. The rule states that when we multiply and the base is the same, in this instance, the A's, which are all the same, we add the exponents. Even though the A, and A does not have exponents at the moment that is showing, we know that if there are no exponents, that there is a 1. If we now add these exponents, we would have A to the power of 4. For the next question, we need to multiply. When we multiply in algebra, we multiply the numbers with the numbers and the letters with the letters. Here we would start off by saying 2 times negative 6 times 0 equates to 0. If we multiply the letters now, we would multiply A times B. In our solution, we would have 0AB now. If we multiply anything with 0, our solution is 0, and therefore the final solution to this question would just be 0. For the next question, we are adding and subtracting, and again, in algebra, we add like terms. If we look at this question, 7A and negative A are like terms as their variables are exactly the same. Positive 11A squared and negative 13A squared are also like terms. So we start off 7A minus 1A is equal to 6A. We then go 11A squared minus 13A squared leaves us with negative 2A squared. We cannot now add or subtract further because an a and an a squared are not like terms. In the next question, we have a division sum. Remember, when we have a fraction, the line represents division. The rule for when we are dividing in algebra is that when we divide and the bases are the same, we subtract the exponents. If we look now, we have a to the power of 4 and we have another a. We need to subtract the exponents and therefore we would go a to the power of 4 minus 1, which results in a to the power of 3. The b's are also the same. They have the same basis. We would have 9 minus 9, which equates to b to the power of 0. Now, anything to the power of 0 is equal to 1. Therefore, we would now have a to the power of 3 multiplied by 1. Anything multiplied by 1 is the number itself, and therefore the solution for this algebraic fraction would be a to the power of 3. Let's move on to the next fraction. Here we have two terms that we need to divide with negative 4a. Because we cannot add a squared and an a, we need to now split this fraction in two. We would say 8a to the power of 2 divided by negative 4a. From this, we would subtract 4a divided by negative 4a. We follow the same rules as we just did with this algebraic fraction. Also, we divide numbers with numbers and the letters with the letters. So here we would start off by saying 8 divided by negative 4 is equal to negative 2. A to the power of 2 minus 1 is equal to a. We now have a negative and a negative together. A negative and a negative results in a positive. We would then go 4 divided by 4 is equal to 1. A divided by a would give us a to the power of 0, which equates to 1. And therefore here we would have 1 times 1, which would result in 1 again. Our final solution therefore is negative 2a plus 1. For our last question, we need to distribute. Outside of the bracket, we have a negative 3. This negative 3 is multiplying with both terms within the bracket. We need to go negative 3 times 4a, but also negative 3 multiplied by positive 7. We would multiply the numbers with the numbers and letters with letters. Negative 3 times 4 is negative 12. There are no other letters and therefore we would have negative 12a. We would now start outside the bracket again with negative 3 times positive 7, which equates to negative 21. Question 5. What must be added to 3a minus a 6 to give us the result of negative 9a minus 6? As we can see, we have negative 6 in the start and also in the end. Therefore, we do not need to add any numerical value to negative 6, as our answer or solution stays exactly the same when we look at the negative 6. The only part where we need to figure out what we added would be we need to ask the question, what happened from 3a to get to negative 9a? And the answer would be we subtracted negative 12a. So the only thing that we need to add to 3a minus 6 to get to negative 9a minus 6 would be negative 12a. The following question says subtract 8y plus 7 from negative 7y squared plus y. We always start with the from part first. Here we would then go negative 7y squared plus y. Because we need to subtract, we need to say minus brackets 8y plus 7. We cannot add the negative 7y squared or the y together. So the first thing we are going to do is distribute the negative sign into this bracket. If we need to rewrite now, we would have negative 7y squared plus y, a negative multiplied by a positive term would salute in a negative 8y, and once again, a negative multiplied by a positive 7 would give us negative 7. Now we can add the like terms together. The only like terms that are present here is the y and the negative 8y. We therefore go negative 7y squared, y minus 8y results in negative 7y, and we just bring down the 7. From question 6, we will be focusing on algebraic equations. If you did question A and B now, you would see that the variables cancelled each other. This occasionally happens, and there's one of two reasons or answers that we can give to this. Let's look at number A. 2x minus 2x results in 0. On the right hand side of the equal sign, we are left with 5. 0 is not equal to 5. And if this happens where the variables cancel out, but the statement is not true, you would write for your final answer that there is no solution to this equation. In number B, if we now move or group the like terms together, we would need to move 5x to the left-hand side, and we need to move the 5 to the right-hand side. Let's start there. I would say 5x minus 5x is equal to the 5 that is left on the right-hand side. Because we are moving the other 5, it turns into negative 5. Now we solve. 5x minus 5x is equal to 0. And 5 minus 5 is also equal to 0. Here again, the variables cancelled out. But the statement is true because 0 is equal to 0. When this happens, we know that the variable that we used within the equation, in this instance x, can be any value. So, for your final answer, you would write that x can be an element of any real number. Number C. Again, we need to move all the like terms to the same side. Here we are going to move negative 3. So we would write down 2x, which is in the right place or position, is equal to the 25 on the right hand side. Because we are moving negative 3 across the equal sign, it turns into positive 3. We now have 2x is equal to 28. We want to remove the 2 from the x because we only want x left in our final answer. To do this, we divide by 2 on both sides. We are now left with x is equal to 14. Number D. Here we need to move variables and numbers. So we would start off by saying 4p, which is in the right position or place, and we are going to move the negative p to the left-hand side. Because we are moving negative p, it becomes positive p, which is equal to 21, which is in the right place. We are going to move the 6 across the equal sign, and therefore the 6 becomes negative 6. 4p plus 1p equals to 5p. 21 minus 6 is equal to 15. We now need to remove the 5 again. As with the previous question, we divide by 5 on both sides. Therefore, p is equal to 3. For our next equation, we first need to do distribution, where we are going to multiply negative 3 with 2y, which is equal to negative 6y, and we are going to multiply negative 3 with positive 3, which is equal to negative 9. On the right hand side, nothing is happening at the moment, so we just rewrite 4y minus 1. We are now going to move all the terms around so that all the like terms are together. We will be moving 4y to the left hand side and negative 9 to the right hand side. If we do this, we would be left with negative 6y minus 4y, which is equal to negative 1 plus 9. Now we add the like terms. Negative 6 plus another negative 4 is equal to negative 10y. And on the right hand side, negative 1 plus 9 is equal to 8. Here we will now divide once again with negative 10, as we want to remove the negative 10 from the y. If we do this, the 10s will cancel out and we will be left with y, which is equal to negative 8 over 10. We can still simplify this fraction further, as 2 can divide into both 8 and into 10. So in our final answer, we would then say that y is equal to negative 4 over 5. For number f now, we start off with a fraction. We have x divided by negative 2. To remove this negative 2, we need to do the opposite operation on the right hand side. So for our next step, we would write down that x is equal to 4. Because the negative 2 was dividing, we would now say multiply by negative 2. X therefore would be equal to negative 8. In G, we now have 12 divided by x. We are first going to remove the x in the same manner as we just did in the previous question. So we will start off by saying 12 is equal to negative 3. Because we have divide by x on the left hand side, we will now say multiply by x. Let me just rewrite. So we will now have 12 is equal to negative 3x. From here, you know exactly what to do. We want to remove the negative 3. So we would divide both sides by negative 3. This then would give us the result of negative 4, which is equal to x. You can also write it differently or swap the x and the negative 4 around and say that x now is equal to negative 4. For number h, which is our last equation that we are going to solve in this manner or in question 6, we have that y squared is equal to 25. In all of the previous equations and what you have learned, we do the opposite on the other side to remove what we do not want on the left hand side. In this instance, it is squared. The opposite of squaring a number would be square rooting a number. And therefore, to remove the square from the y, we would say that y now is equal to the square root of 25. The square root of 25 is equal to 5. Question 7 reads that we need to set up an equation from the information that we are given. And after we have set up this equation, we need to solve it. Let's look at number A. It says that when twice a certain number, to express twice a certain number means to double it. So we would multiply a number by 2. I'm going to choose the letter X, but you can use any letter in this instance. The next part of this states that we need to subtract it from 13. Our keyword is from, which means that this 13 must come first. So we would write 13 minus 2x. Results is equal to 7. Now we have set up our equation and all that is left is to solve it. The negative 2x will stay on the left-hand side and we will move the 13 to the right-hand side. Negative 2x, therefore, is equal to 7 because we are moving the 13. The positive value changes into a negative value. Negative 2x then would be equal to negative 6. Again, we need to remove the negative 2 by dividing both sides with negative 2. Our answer then would be x is equal to 3. This is the last question of section A of this question paper. To do the more advanced algebraic expressions and algebraic equations, make sure to watch the video to follow on section B of this question paper. Okay, let's see. Here we have Army is 6 years older than Tilia. We need to now, because there are two individuals, set up an equation or expression for the age of Army and Tilia. So we would say, for example, that Tilia's age is represented by X. Because Army is 6 years older than Tilia, we would now need to say that Army's age is X plus 6. Because Army is 6 years older than the age of Tilia, which is represented by X. The next part of this now says that together their ages equals to 62. And our final part of this question that we need to answer is, what is the current age of Army now? So to do this, we would start off by adding the two ages together. Tilia's age, which is X, Army's age, which is X plus 6, and together they are 62 years old. X plus X is equal to 2X, and we need to move the 6 across, so we will have 62 minus 6. Now we would have 2X is equal to 56. We need to remove the 2, so we will divide both sides by 2, and therefore X will be equal to 28. But now Tilia's age is represented by just an X. So Tilia would be 28 today. But the final part of the question is asking how old is Army? Therefore we need to say Army's age is equal to X plus 6. X now we found is 28. So 28 plus the 6 would make Army 34 years old today.